Experiment number 11, the JK and D flip-flop. So, ano pa bang hinihintay natin? Let's go!
Here we have some introductory information about JK and D flip-flop. The SR flip-flop can handle a high signal on the SR inputs at the same time. This type of problem may easily be avoided by using gates to prevent this occurrence. One such example is shown below. The inverter connected from the set input to the reset input guarantees that the inputs will never be at the same logic condition. Notice that now there's only one input needed. This resulting configuration is called the D flip-flop. The D flip-flop is named after the single data input. This flip-flop may operate like an ordinary buffer, but its gate input allow it to function differently. The output remains in the current state regardless of the input logic as long as the gate input is low. In other words, the flip-flop can ignore the data in its inputs until it is gated. Another way of going around the problem of the SR flip-flop is to add AND gates to the inputs. This configuration is known as the JK flip-flop. And here are the materials that we're gonna need: 5 volts DC power supply, the 7400 NAND gate, 7408 AND gate, and a software simulator. Here we have our first circuit using the 7400. We have 3 NAND gates. We have the D1 as our switch, in 1, in 2, in 3 as our LED. Now let us proceed for our procedure. Step 1. Initially switch all data switches to off position, switch on the power supply. Next is using the data input, switches 0 to vary the input to the flip-flops. Complete the table below to determine the truth table of the D flip-flop. The third one is describe the operation of the D flip-flop. To answer this procedure, let us test our circuit. Now here we have our circuit number 1. We have here the LS7400, the pin 1, the pin number 7, pin 8 to pin 14. Here we have our in 1, in 2, and in 3 in our D1. And our pin number 7 as our ground, and pin number 14 as our VCC.
Now let us test our first circuit. Let's turn our power supply on for the 5 volts VCC. Here we have our D1 will be in low input. So in 1 and in 2 will turn off, while in 3 will turn on. If D1 is in high input, in 1 and in 2 will turn on, while in 3 will turn off.
For our next procedure, now connect circuit B. Initially turn off all data switches, set the clock frequency to minimum, full counterclockwise, and set the frequency range to low. Switch on the power supply. Now next is switch on D4, which is the K input. What happens to the output? Next is switch on D3, which is the clock input. What happens to the output? And then switch off D3, clock input. What happens to the output? Now next is what is the function of the clock or gate input in the circuit? Next is switch off D4, which is the K input, and repeat steps 7 and 8. That is switch D3 on and off to observe the effect. Next is what effect does the K input, which is the D4, have on the circuit? And last is describe the operation of the JK flip-flop. And to answer all these procedures, let us test our circuit. Here we have our second circuit using the 7400 and the 7408. We have 4 NAND gates and 2 AND gates. We have here the in 4, in 5, in 6, and in 7 as our LED. We have here the clock pulse and the clock D3 and the D4.
Now here we have our second circuit. We have here the LS7408, the LS7400, the J, which is the clock pulse, the K, D4, and our clock D3. We have here the in 4, in 5, in 6, and in 7. And here we have our ground and the VCC, or the positive polarities and the negative polarities. Now let us test our second circuit according to the procedure. The first one is turn off all the data switches, then turn on the power supply. Here we have only the in 7 has turned on. Now let us turn on our D4, which is the K input. Here we have the in6 and in7 are turned on. Now let us turn on our clock. Here we have the in5 and in6 are turned on. Now let us turn off our clock. Now here we have only the in6 has turned on. Now next is let us proceed the same procedure, but the D4 will turn off. Now let us turn off all the data switches and turn on the power supply. Here we have the in7 has turned on. Let's turn off our D4, then turn on the clock. Here we have the in5 and in7 are turned on. Now let's turn off our clock. Here we have the in5 has turned off while the in7 remain on. And that's it for our experimental video, guys. We were able to determine the operation of JK and D flip-flop by answering the following questions in the procedure. Again, guys, I'm Mariza Inamara, and I hope that you learned something from this video, and I hope that you enjoyed it too. Thank you again for watching, guys. See you again. Bye!